The recursive formula to describe a sequence is shown below. A sub 1 is equal to 3, a sub n is equal to 1 plus 2 times a sub n minus 1. State the first four terms of the sequence, and can this sequence be represented using an explicit geometric formula? Let's begin. Okay, so we know that our first term is 3. Now, if we want to find out our second term, this is going to be equal to 1 plus 2 times a sub n minus 1. So in this case, we're going to have a sub 2 minus 1, right? Because a sub n, this n right over here matches this n right over here, right? Which is what we have right over here. So a sub 2 minus 1 is just a sub 1, right? And we know a sub 1 is equal to 3, so we can substitute that in here. So 2 times 3 plus 1 gives us 7. So a sub 2 is equal to 7. In order to find a sub 3, we just do the same process. It's going to be 1 plus 2 times a sub n minus 1. So in this case, we have a sub 3 minus 1, and 3 minus 1 is 2. We know a sub 2 is equal to 7. When we substitute that in here, we get 1 plus 2 times 7, which is 15. And finally, to find out a sub 4, what you do is the same process. 1 plus 2 times a sub 3, and we know a sub 3 is 15, so that means that this is just going to be equal to 31. And this is the first four terms of the sequence. Can this sequence be represented using an explicit geometric formula? So the explicit geometric formula is just going to be a sub n is equal to a sub 1 times r to the n minus 1. Right? This is the explicit geometric formula. If you want to find any term in a geometric sequence, you could use this formula, right? And a geometric sequence, remember, the geometric sequence is something like this, where in order to get from one term to the next term, you're multiplying by some common ratio, right, to get to the next term. For this sequence, it's just going to be the common ratio is 2, right? To get from 2 to 4, multiply by 2. Get from 4 to 8, you also multiply by 2. Now, can we use a geometric formula for this sequence right over here? Well, the answer is no. Now, think about why. In order to get from one term to the next, okay, so we know our first term is 3, right? Our second term is 7. Our third term is 15. Then it's 31. In order to get from one term to the next term, what you do, right, which is stated in our recursive formula, is you add 1 to it. So you add 1 to it, and then you multiply this thing by 2. Now, a geometric sequence, so a geometric sequence we saw when we had this, right? 2, 4, 6, 8, 16, right? A geometric sequence right over here, you're only multiplying by a common ratio, right? You're not adding or subtracting anything, you're only multiplying. However, for this sequence right over here, you're adding and you're multiplying. So there's not actually going to be any common ratio, or there's not going to be like a common difference. So in this case, this this sequence, this recursive sequence right over here, cannot be represented using an explicit formula because it has multiplication involved and it has this addition involved. So there's not going to be any common ratio, or there's not going to be, if this was an arithmetic sequence, right, this one. And this also wouldn't be an arithmetic sequence because it doesn't have a common difference, right? So that is going to be the answer to this problem. Initial investment of $5,000 earns 3.5% annual interest. Recursive model after n years. So whenever you're talking about a recursive model, remember, a recursive formula should have your first term equal to something, and then it should have a second part that looks something like this, where your second part is in terms of a sub n minus 1. For example, the example right over here, right? This is an example of a recursive formula. You have your first term equal to something, and then you have a sub n written in terms of the previous term, or a sub n minus 1. So in this case, I can immediately eliminate 1, and I can immediately eliminate 3, because they don't have the a sub 1 or the a sub n and n minus 1, right? They don't have that. So we could just eliminate those right on the spot. Now let's examine this a little bit further. So we have an account that earns 3.5 annual interest. Okay. Now the thing about interest is basically an annual interest. Annual just means yearly. Annual just means yearly, okay? So your yearly interest is going to be 3.5%. And what that basically means is that basically, right, we start off with $5,000. Basically, what this means, this annual interest, this 3.5 annual interest, what this means is, imagine if you start off with 100% of your savings, basically, right? So 100%, that's 5,000, right? We initially invested $5,000. Now, what's going to happen is next year you're going to have this $5,000, right? But what's going to happen is you're going to add this to 5,000 multiplied by this interest rate, this annual interest rate. In other words, you're going to have 103.5% of what you originally had. Okay? So when you're dealing with these annual interest problems, right? This annual interest represents growth because it's extra 3.5% on top of this 100% that you have. Basically, you're going to have your 100%, right? And then you're going to add it to this 3.5% annual interest. Annual interest. So 100 plus 3.5%, that's going to be 103.5%, which is, if I convert it into decimals, so if I convert it out of a percentage, I'm going to get 1.035, right? And this basically tells you that each year, the amount of money you have increases by 1.035%. Key point that I just wanted to show is basically, right, what you're doing is you're taking the 100%, so your original amount, right? And what you're doing is you're basically adding this 3.5%, right? You're just adding this 3.5% of that amount, right? And in return, you're going to get 103.5% of what you originally had, or 1.035. You can think about this number as basically your common ratio. Common ratio. Because think about it, right? Each year, the amount of money you have is growing by, in this case, 3.5%. So you're going to be left with 103.5% by the end of the next year, right? You're going to have your original amount plus this new amount that you gained. So each year, the amount of money that you earn is going to be increasing, right? The amount of money you have is going to be increasing by a factor of 103.5% every year, or 1.035. So each year, you're going to be multiplying by 1.035. So number 4 is going to be our answer. 0.5% interest, meaning that the amount of money that we have each year is always going to increase, right? You're going to have, in this case, $5,000, and then the next year, you're going to have 103.5% of 5,000, whatever this number is. So the amount of money you have each year is going to be constantly increasing. Now, if you take a look at answer choice number 2, well, notice how each year, the amount of money you have would be decreasing if you were to be multiplying it by 0.035, right? So, number 4 kind of just makes the most logical sense if you think about it like this, right? Because the amount of money you have is always going to be increasing. But for answer choice number 2, because our common ratio is less than 1, you're going to be losing money each year. So this can't be our answer as well, right? Write a recursive formula for the sequence. 8, 20, 50, 125, 3. All right, so what I noticed first is that the amount, basically our numbers are growing exponentially, meaning that it's a potential geometric sequence, meaning that, it involves a common ratio, right? So what we're going to do, I'm just going to take 20, and I'm going to divide it by 8. So in this case, 20 divided by 8 is 2.5. Now let's see if 2.5 is our common ratio. So so we know that 8 times 2.5 gives me 20. 20 times 2.5 gives me 50. 50 times 2.5 gives me 125. So based on this information, we know that this is a geometric sequence, okay? So if you want to find out if the sequence is geometric or not, just take one of the terms, and you just want to divide it by the term behind it. And this is going to give you your common ratio. All right, so if you want to know if a sequence is geometric or not, see if they're, take a term, divide it by the term before it, and see if this common ratio applies for every one of these terms. And if it does, then you have a geometric sequence. All right, now write a recursive formula for the sequence. So you just write a recursive formula. It's just going to be, you list out your first term. So your first term is 8, and you're going to have a sub n is equal to, and it's going to be in terms of the previous term. So basically, the second part of this equation is basically asking you, in order to get a specific term, what do you have to do to the term behind it to get to that term? And in this case, if we were at 125 and we want to get it to 312.5, well, what we would do is we just multiply that by 2.5, right? We said that was the common ratio. So this is going to be your answer. So this basically translates to our first term is equal to 8, and a sub n is going to be equal to our previous term multiplied by 2.5, which, makes sense because, in order to get from one term to the next, you take the previous term and you multiply it by 2.5. The sum of the first 20 terms in this series. Okay. How do I find out the sum of the first 20 terms? Well, first of all, you have to notice that this is actually a geometric sequence as well, or rather geometric series. This is a geometric series. A sequence, so don't get confused with this. So a sequence of numbers is just kind of, you're listing out the numbers, right? Let's say 1, 2, 3, 4, 5. This is a sequence. But a series, you're adding the numbers. So that's the difference between these two. Now, a geometric series, this is an example of a geometric series. So notice the pattern, right? In order to get from one term to the next term, or the next thing that you're adding, multiply by 2. It's just very similar to a geometric sequence, okay? But except you're adding. Now, if you want to find out the sum of a geometric sequence, this is going to be equal to the first term times 1 minus r to the n power, where r is your common ratio and n is the term that you're trying to sum up to, and divided by 1 minus r. So in this case, right over here, we know our first term is equal to -2. And we also know that our common ratio is -3, right? In order to get from -2 to 6, you multiply by -3. In order to get from 6 to -18, multiply by -3, right? So our common ratio is -3. And now that we have these two things, we can solve for the first 20 terms of this series. All right. So the sum of the first 20 terms in this series is going to be equal to the first term, which we know is -2, times 1 minus our common ratio, which is -3. And it's going to be to the n power, so it's going to be to the 20 power, right? Because that's the term you're trying to sum up to, right? These n's should match each other. This is what you're trying to sum up to, right? This is going to be divided by 1 minus -3. So you're going to have -3 to the 20th power, which is a very big number. Okay, I simplified this a bit. I found out what this -3 to 20 is. And just 1 plus 3 gives me 4, right? Because two negatives make a positive. Now, I just have to take 1, I have to subtract it by this. So 4401. And then I divide it by 4. And then I multiply it by -2. And I get 17743392200. And that's going to be the sum of the first 20 terms. Given the geometric series, write a geometric series formula for the sum of the first n terms. Use the formula to find the sum of the first 10 terms. So what is this geometric series right over here? So you can think about this as our kind of second term, right? Our second term, a sub 2, is 360. Our first term is 300. Our third term is 432, right? So, and we know that this is a geometric series, meaning that this is going to have a common ratio. So we know that in order to find the common ratio, just take one term and divide it by the term before it, and this gives you the common ratio. So in this case, let me just take 360 and divide it by 300. And this is going to give me 1.2, and that's going to be my common ratio. So yeah, just take one of the terms and just divide it by the term behind it. Preferably, you're dealing with like the smallest numbers so that the calculations are simpler. Anyways, now that we know what our first term is equal to, we know our first term is equal to 300, and we know what our common ratio is equal to. So we can write out a geometric series formula for the sum of the first n terms. So for this geometric series, if we want to find the sum of the first n terms, it's going to be our first term, a sub n, right? Actually, let me just scroll here. It's literally just going to be the exact same formula as this that we did before, except we know what a sub 1 is equal to, and we know what r is equal to. Just substitute it in here. And yeah, that's the geometric series sum for this formula. So remember, it's going to be your first term, which is 300, times 1 minus your common ratio, which we know is 1.2, to the n power, and it's going to be subtracted by 1 minus 1.2, which is negative 0.2. And yeah, that's the sum formula for this series, up to the nth term. Now, if I want to find out the sum of the first 10 terms, what I do is I just replace this n with 10. So yeah, and we get 300 times 1 minus 1.2 to the 10th power divided by negative 0.2. So 1.2 to the 10th power is going to be that. It says round to the nearest 10th, so also make sure to do that. So it's going to be 7787.6. And that's going to be our answer. Evaluate the series. This. What the hell is sigma notation? So this right over here is sigma. Now, how do we do this? So imagine that we have a series. So this is basically a series in disguise. So imagine if we have the series 1 plus 2 plus 4 plus 8 plus 16. All right. So our first term, let's just label this as a sub 1, and our second, third, fourth, fifth term is 16. Now, what we're basically doing, and this is the way you represent it, is you're going from the first term to the fifth term. And for each term, what you're doing is you're multiplying this by 2. What this is basically doing is you're taking all the integers between 1 to 5, so you're also taking 2, 3, and 4, and you're basically putting it into this formula right over here, and you're adding all of it up. So let me show you what I mean. So you're starting at 1, right? So n is equal to 1. If we plug 1 into this formula, we're going to get 2. All right. Now what you're going to do is you're going to plug the next integer into this formula, right? You just plug the next number into this formula. So 2 times 2, right? You're going to plug 2 into n. So 2 times 2 gives me 4, right? Then you're going to go up 1 again. So 3, you're going to plug in 3 for n. So 2 times 3 is 6, right? And then you're going to go up to 4. So 2 times 4 is 8. And then finally, this represents your last term. So this number up top represents your last term. So if you plug in 5 in for n, you're going to get 10, and then you stop. All right. So this number at the bottom tells you your starting point. This number on the top tells you your kind of stopping point. Okay. And you're going to be summing for all the integers or all, the whole numbers, whatever, that's in between these two numbers. So if it's from 1 to 5, you're also doing the sum for 2, 3, 4, and then 5. Okay. So in this case, if I want to evaluate this series right over here, what I do is first I plug in 1 in for n. So I'm going to have 40 minus 1 squared, which is 39. Then what I'm going to do is, actually, let me leave it in this form so maybe it's a bit clearer. So we're going to have 40 minus 1 squared. Next, what you're going to do is you're going to add, 40 minus 2 squared. So you're just going to, and the next term is going to be 40 minus 3 squared, right? So all it's doing is you're basically plugging in numbers from 1 to 7. So you're plugging in 1, n is equal to 1, n is equal to 2, 3, 4, 5, 6, all the way up to 7. And then that's when you stop. So when you plug in 2 in for n, you get 40 minus 2 squared, right? If you plug in 3 in for n, you get 40 minus 3 squared. And then you get, 40 minus 4 squared, and then 40 minus 5 squared, and, so on. Now, you should probably show work for this, but this is also like, if you're during a test and, you really don't know the answer to this, there is a calculator option for this. You're going to press math, and it's going to take you to this page. You're going to go all the way down, and then there's a summation button. You're going to press enter, and boom, you have the summation. So in this case, this is we said how this is going to be from 1 to 7. So we said how this is going to be from 1 to 7 for 40 minus n squared, right? And it's going to give me 140. So that is going to be my answer. Right? But, if you want to show this algebraically, you have to write out, the whole thing. So 40 minus 5 squared, 40 minus 6 squared, 40 minus 7 squared. That's when you stop. And then you just, add all this. Finally, this problem is kind of like the same thing, right? So it's going to be, you're doing this from 1 to 7. So it's going to be 30. First, you're going to have 30 minus 1 plus, and then 30 minus 2, right? Plus 30 minus 3, and then so on. And then, just make sure to show all the work. And then when you get up to 7, then that's when you stop. And then you could just use your, calculator. So you're just going to go to math. Going to go to summation, and this is going to be you're going from 1 to 7, right? And in this case, we have 30 minus k, so it's going to be 30 minus this, 182, and that's going to be our answer. We have this. Rewrite using sigma notation. So our first term is equal to 1/2. Our second term is equal to 2 over 3. Third term is equal to 3 over 4, and so on. Okay. Now, first of all, I want you to count how many terms there are. So this is going to be 1, 2, 3, 4, 5, 6. There's 6 terms in total, okay? So that means that when I'm writing this thing in sigma notation, I'm going to start from n is equal to some number, right? Let's say if I'm starting at n is equal to 1, then my top value should be n is equal to 6, okay? Because I'm summing the numbers from 1 to 6, all right? Now notice how the numerator increases by 1 each time, and the denominator increases by 1 each time. So what I'm going to have is you're going to have your first term is 1/2. Your first term is 1/2. You're going to be adding n to it. It's going to be n minus 1, actually. Maybe this. All right. So this is actually going to be the answer to it. Now, you might be wondering, where the hell did I get this from? Well, you can think about it like this, right? So if I just left the answer as 1 plus n divided by 2 plus n, and this is going to be summed up from 1 to 6, what's going to happen is our first term, if I wanted to find out what my first term is equal to, I would plug in n is equal to 1 into this series. So I would get 1 plus 1 divided by 2 plus 1, or I would get 2 over 3. Now the problem with this is we know our first term is 1/2, not 2 over 3, right? 2 over 3 represents the second term, not the first term. So in order to fix this, what I do is I add n minus 1. I'll just put it in parentheses. But I'm just making it clear. This is just to make clear that, when I put in n is equal to 1, so let's say if I put in n is equal to 1 into my summation, well, my first term is 1 plus, when n is equal to 1, I have 1 minus 1 divided by 2 plus 1 minus 1, right? And then I will just get 1/2, which is my first term. If I plug in n is equal to 2 into my summation, I'm going to get 1 plus 2 minus 1 divided by 2 plus 2 minus 1, right? And then now, this is just going to be 2 minus 1 is 1, 1 plus 1 is 2. 2 minus 1 is 1, 1 plus 2 is 3, right? So notice how every time, we're just going to be adding the numerator and the denominator by 1 as we increase from n is equal to 1 to 2, 3, 4, and 5, 6, all right? And that's just going to be an answer. You can also simplify this a bit. We know that 1 minus 1 is 0. And we also know that 2 minus 1 is equal to 1. So if you write your answer like this, where it's from n is equal to 1 to 6 of n divided by 1 plus n, this also works. But I'll just write it like this, kind of just to show y'all kind of the process. All right. But yeah, that's basically it.